I will move this circle to be this center, which is H and K. I will move it to this 0, 0. Why? Because it's easier for us to understand the circle. So I'm going to make another layer here. So I'm going to make X and Y axis. This is Y axis. This is X axis. That's our favorite X and Y. And we're going to have a circle on the center. So it's going to go right here. All right. So center of this circle is 0, 0. And the radius, which is this much, this is a radius, correct? Or this is a radius. I will call it R. This point, for example, P, on the circle creates an angle here. We can call that angle anything you like, but in this course, we will label it alpha, beta, or theta. So that's only a label. So I'm going to call it alpha. Correct? So today we're going to learn how do we measure the alpha. Good. Going to review it. So few keyword here. So I'm going to hide those layers. We call this an array. This is an array because this tells us it's going to go to infinity. If we have a line, if it's like this, as an endpoint, they call it segments. But we're dealing with the array in this course. So this is an array, and I make another one there. These two arrays create an angle here. This is an angle. This array, they call it initial side. So that's what we call it. And the end, the one that at the end, they call it, what do you call it? Initial and end, terminal side. So as you see, I went this direction, which is plus. So we have initial side, and we have terminal side. Another example, initial side always is like this, one horizontal line. Now I create beta. So this is initial. And this is terminal side. They create beta. This beta will be negative. Beta will be less than 0. Good. So we have another one, they call it coterminal coterminal is, for example, this is the initial. Let's create an theta here. Good. So this is initial. That's a terminal site. If I make another one, so initial always is like this. If I make another one all the way back to this one, that's a possible angle, correct? Like a 400. So then theta and alpha will be coterminal. That means they are sharing initial value and terminal value. Any question here? So those are the definition. Initial side is always a horizontal line. If you go this way, it's positive. The other way will be negative. The coterminal is very important, that they're sharing the same initial and same terminal side. For example, theta equal to 40 degree and alpha equal to 400 degrees. If we graph them, for example, 40 degree, this is 42, that's 40, correct? This is 40 degree. If I want to make 400 degree, this is theta. Now I'm going to make alpha, which is 400. 400 means we're going to go 360 degree. So this 400 will be 360 degree plus 40 degree, correct? So 361 revolution, and then I go to the 40 degree. So I will end up to have a same terminal side. So therefore, alpha and theta will be coterminal. That means they are sharing same sides. Please stop me if you guys have any question. Initial sign.
Professor, can you go back to that really quick?
Sure.
That's good. Thank you.
Took a picture.
Yeah, I did.
I'm recording it. I put it in YouTube too. Okay. But you guys also have an ebook online, correct? You should be able to access the book online. All right, let's go back to the initial side. And we have another 90 degree. Good. Let's make one 30 degree. This is like, I want to be different color. This is 30 degree. So this is 30 degree. Good. And this guy, everything is 90. So if this is alpha, what is the measure of beta?
60.
Very good. How do we know it's 60 degree? Because this notation means 90 degree. So alpha plus beta become 90 degrees, correct? Because you add them, you get this. Alpha was 30, so therefore beta should be 60. If you see an angle like this, when you add them, you get 90, there is a name for it. They call it complementary angle. So alpha and beta will be complementary angle. Let's have another one. Oops. This is 25 degree. I'm going to call it theta. Theta is 25 degree. We have a straight line. This is straight line. What is the degree of this angle?
180.
Yeah, everything, if you go all the way to the original, it will be 360 degree. They call it 1 revolution. If it's half of that, so it will be 180. So everything will be 180. So what do you think? I'm going to call theta and alpha, beta. Lambda will be. What's the angle of lambda if it's just this much?
155.
155 degrees. So we also need to know, there's a name for this one. They call it supplementary. So lambda plus theta give us 180. So this is something that we love it. We didn't put a name for it. They call it supplementary. All right. So I think you guys know all the definition now. So let's have one question for you guys to wake you guys up. One quiz. Alpha equal to x plus 5, beta equal to 2x plus 25. Good. Alpha and beta are complementary. They're complementary angles. Then solve for x. What is x? Who wants to answer this? Maria.
Yeah, I'm still working on it.
Is it 20?
X is 20.
That's my guess anyway.
You're guessing?
I mean, I did the math, but I'm not sure it's right. So I'm
Well,
saying guessing.
Jason said x equal to 20. That means alpha going to be 20 plus 5. equal to 25. Beta is 2 times 20 plus 25 will be 40 plus 25 equal to 65. 65 plus 25, if you add them, you get 90 degrees. Very good. So it's correct. They become complementary. So do you see that in this layer, I just introduced you guys what is complementary, what is supplementary. You guys took a picture, you loved it, it was so pretty. Not so pretty, I mean, everything was okay, but the way we question you guys, a little challenging. So the same topic, then I bring something in terms of X. Good. So what's the keyword here? The complementary. So in your note sheet, you know complementary angles, when you add them, you should get 90 degrees. Good. So that means alpha plus beta is 90 degrees. So that's how we start. Then alpha has x plus 5. So I put x plus 5 for alpha and 2x plus 25 for beta. So that's how Jason solves it. Put x plus 5 plus 2x plus 25 equal to 90 degrees. So now we have one equation, one unknown, which is x. X plus 2x is 3x plus 30 equal to 90 degrees, minus 30 minus 30. Then we have 3x equal to 60 divided by 3, x equal to 20 degrees, or 20. On your homework, they might ask you guys solve for x, or they might ask you guys what is alpha, but what is beta. If they're not looking for x, but they just ask you what is alpha and beta, so your job is to plug it in, same as I did. So alpha is 25, beta is 65. Any question here? All right, very good, Jason. Very good. So now let's back to our circle. Good. We are here. So this alpha, so we're gonna go this direction, which is plus, and the other direction will be negative. If we go one revolution, will be 360 degrees. So from 0, we go to 360 degrees. What does it mean? Why is 360 degrees? That means if so here you see on the screen 0 degree here on the bottom of the page. All the cameras are correct. You see 0 degree, angle 0. Yes. So now if I move this one, little, become 3 degrees. I want to see if I can get 1. This is 1, but we need to have a sharp. So this is 1. Let's go back to, this is 5. Good. So what does it mean? It means from here, so there are 5 degrees there. This much is 5 degrees. Good. That means we have 5 of those lines. Then this is going to be, for example, 6 degrees. This is going to be, oops. why did I, that's this going to be 7, this going to be 8 or 10. Good, you get the idea? If I go all the way, then to this point, for example, it's going to be, this will be 359, and the last one is 360. That means in one circle, I can divide it to 360 pieces. Good? So 360 degrees of the circle, that means we can just chop it up to 360 of them. All of them has a center here. Initial side is there, but terminal side, we're gonna have 360 all the way. So now the question is, let's say we have a point, like point P, correct? Point P looks like exactly as 41 degree. So this is 41 degree. Good. Let's say there's another point Q here. Point Q and this is 42. I'm going to call this one K, for example. So K is 42 degree and alpha is 41. What do you think what is the Q equal to? How big is the measure of Q?
Half a degree.
For example, 41.5.
Oh yeah.
For example, yeah, approximately 41.5. So I'm gonna have little parenthesis here. Under ruler that we already know how to read, for example, this is 0, that's 1 inch, then we go to 2 inches, correct? If you want to measure something, if it's 2 inches, we are good. We are able to read it. But sometimes, for example, let's say we're going to measure this. We're going to see how big is A to B. So A to B is not 1 inch, correct? It's less than 1 inch. So because it's less than 1 inch, we have another unit. We said, okay, this is like a half an inch. Then we got 1/4 of inch. This is 3/4 of inch. Then we have 1/8, right? We divide it to different pieces to be able to find the exact measure of AB. So we're doing the same thing for the angle. Is not only degrees. So 1 degree, so 1 degree, I don't know what those all are. So you guys know what is 1 degree, correct? You guys know that I just chopped it up to 360 and 1 degree was a super small thing. In 1 degree, for example, if this much is 1 degree, we are able, I'm going to make this as a little bigger. So let's say we zoom in. This is 1 degree. Good. This 1 degree, we are able to chop it up to 60 more the small thing that you see, we can divide it to 60. Each one gonna be 1 minute. So we are dealing with minutes. What is minutes? 1 degree that you see a small one like this much equal to 60 minutes. Now, let's say our point that we were looking for to see what is the exact value, like a point Q, let's say is not gonna be on the minute as well. Let's say it's here. And it is not on the line of the minute. What we do, if this is 1 minute, if this much is 1 minute, which should be super, super, super tiny, we will divide. So I'm going to zoom this one in again. So this is 1 minute. I'm going to zoom in. I can divide it to 60 more. Each one will be 1 second. So 1 minute equal to 60 seconds. Are you guys following me, Jake?
I'm sorry, this might be dumb. Are they really called minutes and seconds? Like
Yes,
that's
yeah.
okay.
Do you have different name for it?
No, I didn't know if it was like an analogy, or if that's what it
Yeah,
was.
it's, actually it's coming from the clock. So now let's go back to what we had. So now you learn the units of the 1 degree. You guys like this? Oh, great. You can divide the circle to 360 pieces, and then each one is 1 degree. Then 1 degree, we said, oh, inside of 1 degree is 60 minutes, correct? And inside of 1 minute is 60 seconds. That's the notation of minute and second. Oops. Good, this is second, that's minute. Now, can you guys tell me inside of 1 degree, inside of 1 degree, how many seconds do we have?
$360.
How much?
360.
3,600?
360, or maybe, yeah, 3060, sorry. 2 zeros, yeah.
You multiply them, very good.
Yeah.
So those things can go to your note sheet that you, in case if I ask you guys, because this is like a 1 degree, has 60 of minutes. Inside of one of them has another 60. So 60 here, 60 here, but we have 60, all of them divide by 60. So 60 multiplied by 60 give us 3,600. Can you guys visualize it? How do we divide? But why do we need it? Yeah, we need it, for example, let's say we have some treasure or Bitcoin somewhere in the world. How do we give that coordinates? They go that details to say, okay, go 45 degrees to left, 4 minutes and 5 seconds, then you're going to get that point, right? So that's the unit that the airline, they use this type of unit as well. So the type of question that you will see here, example, you know, you guys love this when you learn, but when I make an example of quiz, you guys freaking out. So I give you guys 42.31 degree, correct? (42.31 degree). Can we graph this? I mean, in my iPad, I cannot go. I can go to 40. For example, 42 here. This is 42. But if I go, I'm going to go 42, and 0.31 is complicated. But let's say we are able to make 42.31 with one type of application. But the question that we have, this is 42.31 degree, and we would like to convert this to minutes and second. Let's say there is a computer here, or there is a robot that doesn't understand decimal on degrees, only understand degree, minute, and second. That's how they're only, so only this guy understand this. And if you convert it, this robot can find Bitcoin for you guys. So how do we convert? So the question that you will see in homework, I give you guys degrees like this, in decimal or everything, and I ask you guys make it to minute and second. Or I give you guys in this format, I ask you guys to make it in this format. So we're converting. Got it? So how do we convert this 42.31 to degree, minute, and second? So let me make some room here. So this will happen only on the first exam. So do not freak out if you, I mean, is easy to get the point, is not the, so you're gonna have it in your note sheets. How do we do it? So we have (42.31 degree). Can I write this in terms of 42 plus 0.31? Is that same? So we are doing some algebra cheating. Is this exactly the same, correct? So now, so this 42, our robot understands. Oh, 42 exactly whole number understand, but not the decimal. So 42, I'm gonna write it here in this. So 42 is done. Plus 0.31 degree, I'm gonna cheat again. I'm gonna say 0.31 multiply by 1 degree. So now the unit of 0.31 is like a count that has no units. But I mean 0.31, if you multiply this by 1, you will get 0.31, right? So I just want to get 1 degree out because I know 1 degree equal to 60 minutes. So that's what I'm going to do. So we have 42 degrees plus 0.31 multiplied by 60 minutes. So what is 0.31 multiplied by 60? Ask Elizabeth to do it. Who has a calculator?
18.6.
Okay, thanks. So this is 18.6. So 42 degree plus, what is a unit of 18.6? When I multiply this, the only one that has unit is a minute, correct? So everything will be minutes, 18.6 minutes. So I do the cheating again. This will be 42 degrees plus 18 minutes, correct? Plus 0.6 minutes. Because 18 plus 0.6 give us 18.6, correct? This is exactly 18.6. 42 degrees plus 18 minutes plus 0.6 multiplied by 1 minute. What is 1 minute? We know 1 minute is 60 seconds. Good. So what I'm going to do, I'm going to bring, instead of 1 minute, I'm going to put 60 seconds. So we have 42 degrees plus 18 minutes plus 0.6 multiplied by 60 seconds. What is 0.6 times 60?
36.
Okay, 18 minutes. So this is going to be 36, and the unit is second. So we are done. 42.31, this is exactly as 42 degrees, 18 minutes, 36 seconds. And I'm not going to put plus, so the plus will go away. So this will be something to insert inside of your robot to understand, to only understand this one. Was too much, Mario?
No, I understood.
I know it makes sense, but you guys need to have a little more practice to do it correct in exam. So now let's have another one, different way. I'll give you guys in degree, minute, and second, and ask you guys make it to decimal. So we have 19. I don't know why it does that. 19 degree and 39 minutes, correct? This is our alpha from the robots. 19 degree and we are able, in this iPad, I'm able to make like 19. This is 19. But how do I go to 39 minutes? So my system doesn't understand. I know I have to go a little more, but how much more? There's so many, points are there. So we're gonna make this one. So the way you see it in the question, in your homework, they are saying convert (19 degree and 39 minutes) to decimal degree. Good. So that's type of question. You see that this is in degree, minute, and second. So we have to make. So again, algebra here. Alpha equal to 19 degree. And I'm going to say plus 39 multiplied by 1 minute. Oh, we have waiting room. Who is in the waiting room? Oh, it's gone. I missed somebody in the waiting room. So we are here. What can I write instead of 1 minute? How, inside of 1 minute, how many degrees do we have? So we learned that 1 minute equal to 60 seconds, okay? But 1 degree equal to 60 minutes we are dealing here. 1 degree is 60 minutes. 1 minute has 1/60 degrees. So instead of 1 minute, I will put 1/60. 39 times that. So now this become in terms of degree. So we have 19 degree plus 39 times 1/60. What do we get here? What is 39 divided by 60? $39.
0.65 maybe.
0.65, yeah? 0.65 degree. So the final answer when you add them, now both of them has degree and degree, it will be 19.65 degree. Good. So now you know how to convert DMS to decimal in degrees. Question? No question. All right, let's go back to real business here. This is out. We talked about this. All right, so we have a circle. Inside of the circle, if we read the measure, this one is plus. Start from 0. So the x-axis, this part always is, this is the initial side, correct? We go this way or that way. Plus, we go to 90 degrees, we get to 180 degrees, we get to 270 degrees, and 360 degrees. We also learn a little bit about the radians. So degrees out, you know it very well now, correct? You know, degree, minutes, seconds. So another unit is radiant. Radians. When one radiance happens, so this is R, correct, radius. This is R. If this arc, if this is equal to R, if all of them are same, then this will be 1 radians. So if R equal to 1, if it's a unit circle, then this will be 1. Another one, for example, going to be, this is 2 radians. We have 3 radians, 4 radians, 5, and almost 6. All right. Any question about radians? So this 360 will be 2 pi in radians. 180 will be pi in radians. And 90 degree will be pi half. 270 will be 3 pi half. So I'm going to go over radiant again. In your homework, you don't have anything about the radiant yet. Don't think there's any question about radiant, but let's have a couple homework questions here. Solve for x. No, they said find the measure of each angle. So what do we know about these two angles? We know if we add them, what should we get?
180.
Yes. So give us 18x equal to 180 degrees divided by 18. X will be 10. So x will be 10 degrees, but you cannot leave it like this. They said find the measure of each angle. So you have to plug it back. This is going to be 110 degrees. This is going to be 70 degrees. Another question is like this, I see it. This is negative 4x degrees. This is negative 14x degrees. So again, these two create a straight line. So when you add them, we should get 180. X will be negative 10. Negative 10 goes here, will be positive 40 degrees. This is going to be 140 degrees.